Welcome back, Algebra 1. This is Lesson 92, Uniform Motion Problems about Equal Distances. This is actually an exciting lesson for you. It's going to be the first time you're introduced to these rate, time, distance charts. So let's just take a moment to review what this is. In science class, you're going to study quite a bit of your distance charts or distance formulas. There's a science formula that says distance is equal to rate times time. Sometimes we refer to that as the DIRT formula using the letters DRT. So these tables are going to be your DIRT charts. We have rate times time equals distance. It's just a uniform formula that you'll have in math and science classes. You're going to want to have your textbook nearby because we are starting out with an ABC question straight from your book. This is on page 386. Candida and Pangloss walked to the site of the disaster in 9 hours. The next morning, they jogged back home in 3 hours. How far did they jog if they jogged 4 miles per hour faster than they walked? Well, we see that our chart has this listed as 2 rows. 2 different scenarios are going to happen. We're going to have a walk there, and we have a jog back. So I'm going to go ahead and label it walk there, jog back. Those are the 2 scenarios that present different rates. And then I pull information from what we just read. It took 9 hours to walk there, so that goes in the time. And then when they jogged back, it only took 3 hours. How far did they jog, meaning what is their distance, if they jogged 4 miles per hour faster than they walked? So we don't know what our rate for walking is, but we know jogging was 4 more than that, 4 miles per hour faster. So I'm going to put rate plus 4. Okay, and then since it is rate times time equals distance, you're going to multiply the 2 columns that we already have filled in. So 9 times r, and then 3 times r plus 4, and that's what our distance is. Then you're going to double check in this equation that they both had the same distance. Well, if we walk there and jog back, that distance there and that distance back are going to be equal to each other. So I take my first distance, 9r, and set it equal to my jog back distance, 3 times r plus 4. Okay, so I'm setting the distances equal to each other. Then I distribute the 3. And I get 9r equals 3r plus 12. Go ahead and subtract 3r from each side. And I get 6r equals 12. Divide both sides by 6. And we have r equals 2. Now before we box in, let's just go back and see what the question is asking. How far did they jog? Well, we found the rate for the walk there, but we did not find how far. How far means what is the distance. So how do we find the distance? Well, we can use either of these 2 equations up here in our table. I'm going to choose the shorter one, 9 times r. And so I'm going to solve that. 9 times r. We just found what r is equal to. It's equal to 2. Therefore, my distance is 18. And I check my unit from the problem, and it's going to be 18 miles. So my solution is 18 miles. Going on to question B. On Monday, Voltaire drove to town at 60 miles per hour. On Tuesday, he drove to town at 40 miles per hour. If the total traveling time for both trips was 15 hours, how far was it to town? So this separation, he's driving to town both times. So I'm going to separate it by titling it Monday's trip and Tuesday. Having a little issue with my pen here, so let's just go a little bigger. And then we drove to town at 60 miles per hour for Monday. 60 miles per hour is a rate. That's how fast we're going. On Tuesday, it was 40 miles per hour. This is the tricky part. It took 15 hours between the two times total. Okay, so the two together add up to 15 hours. How we break that down then to put in the chart is we're going to call one of them T, and the other one is 15 takeaway T. Okay, now we're ready to multiply across to get our distance. So remember, we do rate times distance equals rate times time equals distance. So on the top I get 60t, and on the bottom I'm going to have 40, but that's going to distribute across 15 minus t. Okay, once again our distances are set equal to each other because it's the same trip, just different days. So I'm going to have 60t set equal to 40, and that's going to distribute across 15 minus t. Okay, so the first thing I'm going to do is distribute that 40. 40 times 15, that gives me 600 minus 40t. Let's add the 40t back over to the left side where the t's belong, and I get 100t equals 600. Now I'm going to divide both sides by 100 to get t equals 6. So I found that my time was 6 hours for Monday. However, I need to go back to find not the time, but the distance. Okay, the question says, how far was it to town? So if I were to go back and choose a distance and plug in my new t value that I found, distance is 60 times t. So in this case, 60 times 6. And therefore distance is equal to 360 miles. Okay, that's it for question B. We do have a few homework questions. We're going to go ahead and do questions 1 and 2 together, and that leaves you with not too many on your own. So starting in with question 1, this is still from page 386. In the morning, the passenger train made the trip in 3 hours. In the afternoon, the freight train made the same trip in 7 hours. Find the rate of each if the rate of the freight train was 40 miles per hour less than the rate of the passenger train. Begin by drawing a diagram of distances traveled and writing the distance equation. Okay, when he asks you to draw a diagram, I've already put the chart in here for you, so that is essentially our diagram. So we're going to go back and pull information. The two things that are happening in this one is we have a passenger train and we have a freight train. They're the ones that have different rates. Okay, the passenger train made the trip in 3 hours, so that is his time. The same trip for the freight train took 7 hours, so I plug that into the time. Then the other information that I'm given is the freight train was 40 miles per hour less than the rate of the passenger train. So if I called the passenger train R, the freight train is going to be R minus 40. It's 40 less than that. Remember that it is rate times time equals distance. So I multiply across and I get 3R. Then I'm also going to have 7 is going to distribute to R minus 40. All right, my two distances are equal to each other. So I set up the first distance, 3R, is equal to 7 times R minus 40. Distribute that 7 across. and I get 7r minus 280. And from here, we're going to do some algebra. Let's subtract the 7r back to the left side, and I get negative 4r equals negative 280. Divide both sides by negative 4, and r is equal to 70. Now what I found there when I found r, right here is where that r is all by itself. So I found the passenger rate, and I need to find both passenger and freight. But I did find half of my solution here, so 70, my units would be given in the problem, and it was, I believe, miles per hour. So I'm going to put miles per hour, but I need to label that this is the passenger. Okay. Then I still have to find the freight, miles per hour. So I go back up to look at the freight rate, and it says to take the R value and subtract 40. Okay, so 70 subtract 40. So my freight rate is going to be 30 miles per hour. All right, so those are my two solutions. That was question 1. Now let's go over to question 2. Vanessa rode her bike to the conclave at 10 kilometers per hour and then walked back to school at 4 kilometers per hour. If the round trip took her 14 hours, how far was it to the site of the conclave? Begin by drawing a diagram of distances traveled and writing the distance equation. I already have the diagram and the distance equation for you, so we just need to figure out how we break this up into 2 different distances. The first half of this trip was riding a bike to the conclave, so I'm going to call it bike. The second half, she is walking back to school, so it's bike versus walk. Then the other information that was given is that it took 10 kilometers per hour rate on the biking and 4 kilometers per hour for the walking. The round trip took 14 hours. Okay, so this is the tricky type where I have to think about the two together add up to 14 hours. So I'm going to call one of them t and the other one 14 minus t. Okay, then I'm going to multiply across. Rate times time equals distance. So 10 times t, 4 times 14 minus t. Set these distances equal to each other. And my next step is I'm going to have to distribute that 4 across. So 4 times 14 is 56 minus 14. Add the 4t over to the left side of the equation. So now we have 14t equals 56. Divide both sides by 14, and I get t equals 4. But I double check, what was the question asking for? Did it want the time? And it's asking for how far was it to the conclave. So no, when it asks how far, it's asking for distance. So I need to go back up to the equation and find what says distance. 10 times t, that represents distance. So I take 10t and I plug in my new t value is 4. And then that means my distance is equal to 40 kilometers. Okay, that is for question 2. And that's all the homework I'm helping you with at this time. Looks like you have 6 problems on your own. Good luck.